In the last section of test 3 period, we're going to talk about general solutions. Whenever we are given with a trigonometric equation and we want to solve for the indeterminate or the variable term in the equation, we get infinitely many solutions. Remember, all trigonometric functions are periodic functions. So after every period unit, we are expected to repeat the same value. So we would learn how to write the solutions in a general format that encompasses all possible solutions for a particular trigonometric equation. So instead of talking about the general procedure of solving trigonometric equations, we'll start with specific examples and we will learn the process. The first example is cosine x equal to negative square root of 2 over 2. Think about in which quadrants cosine is negative. The answer is second and third. Then we ask ourselves, this ratio of square root of 2 over 2 is for which angle? And remember, I'm saying square root of 2 over 2. I'm not talking about negative. I just want the acute angle for which the value is the magnitude of the value that we have been given. So that is going to be at pi over 4, which tells me immediately that the reference angle in both situations is going to be pi over 4. So now we will draw the angles in the second and the third quadrant with the reference angles of pi over 4. So for example, this is the second quadrant with pi over 4. This is the third quadrant with pi over 4. And in either situation, I will require the angle in the standard position to know the solution. So the first one in second quadrant is 3 pi over 4. The second one in the third quadrant is 5 pi over 4. So these are the first two solutions. But as I am going to write down all the solutions, I will now say x is equal to 2k pi, k is the standard integer variable, plus either 3 pi over 4 or 5 pi over 4. So these are the two sets of solutions for k equal to 0, plus or minus 1, plus or minus 2, and so on and so on. That answers the first question. So this is the work that we're going to repeat. Why we added this term 2k pi? Because both sine and cosine function has a period of 2 pi units. So we want the integer multiple of 2 pi in order to establish the very fact of having values that are repeated and gives us the ratio of negative square root of 2 over 2. Similar question for sine this time. So first think about the magnitude of this value, that's square root of 3 over 2, and think about sine will be square root of 3 over 2 at which angle? Answer is pi over 3. Okay? But sine is negative in the third or the fourth quadrant, so the two reference angles of pi over 3, one is in the third quadrant, so that's the reference angle, or in the fourth quadrant, which is this is the reference angle. Draw them in standard position. So first one is going to be this, and that's pi plus pi over 3, which is 4 pi over 3. The second one is this, which is 2 pi minus pi over 3, and that is 5 pi over 3. Okay, so now what? Now we are going to write down the solution in general format. So we say, again, period of sine is 2 pi, so you need the integer multiple of 2 pi, write it as 2k pi, plus either it will be of the form 4 pi over 3, or it is going to be of the form 5 pi over 3. And I just have to say what are the values for k? Well, the possible values are 0 plus or minus 1 plus or minus 2, and so on. The next one is a little more intricate because I do not have the trigonometric ratio by itself. So what I do, I solve it for cosine x first. So add square root of 3 on both sides. You get 2 cosine x equal to square root of 3. So cosine x is square root of 3 over 2. It's already positive. Cosine is going to be square root of 3 over 2 if the angle is pi over 6. And I am in the first quadrant or in the fourth quadrant where cosine is positive. First quadrant is pretty simple. The angle is itself pi over 6. Whereas in the fourth quadrant, the reference angle is pi over 6. So the angle in the standard position is 2 pi minus pi over 6, which is 11 pi over 6. And then that gives us the solution. X period is 2 pi, so 2k pi plus pi over 6, or 2k pi plus 5, that should be 11 pi over 6, so I should be careful while writing it. Pi over 6, and this is 11 pi over 6. Again, k is 0, plus or minus 1, plus or minus 2. All the integer values. If possible, find a solution to cosine theta plus 3 equal to negative 10. If no solution exists, enter none. Remember, I don't have to solve this thing because the range of the cosine function is between negative 10 and 10. So range of cosine is negative 1 and 1. I said negative 10 and 10, but negative 1 and 1. That is the range. This value is outside the range. So there is no solution. So I will say no solution, and in top hat, when I'm answering, I will say none. Oh, or I will read the instruction. And that is your general procedure. Now we have tangent t equal to 1 over tangent t, and I want to know all solutions in the interval of 0 to 2 pi. And it says, first estimate the solution from a graph, then find the exact answers. Enter your answers in a comma-separated list. So I do not need to know all the solutions, only the solutions that are between 0 and 2 pi. So let's start with the equation, tangent t equal to 1 over tangent t. I want to get tangent t by itself, so I'm going to multiply tangent t on both sides so that I can get rid of the tangent t from the bottom. If I do so, left-hand side becomes tangent square t. Right-hand side is 1, so I take the square roots on both sides. Do not forget you get absolute value of tangent t equal to 1. So twofold solution. Either I get tangent of t equal to 1, or I get tangent of t equal to negative 1. The good thing is, I know the reference angle for both of these answers are going to be the same because the magnitude of the value is still 1. And tangent is 1 when t is pi over 4. So that is the reference angle. So first quadrant where tangent is positive, it's pretty cool. It's just pi over 4. Second quadrant tangent is negative. If the reference angle is pi over 4, then the actual angle is 3 pi over 4. So that's one other solution. The third quadrant, the reference angle is pi over 4. So the angle in the standard position is 5 pi over 4. And finally, in the fourth quadrant, if the reference angle is pi over 4, the angle in the standard position is 2 pi minus pi over 4, which is 7 pi over 4. And all of them are going to be my solution. Pi over 4 and 5 pi over 4 in the first and in the third are positive ones, and the negative ones are going to be in the second and the fourth as 3 pi over 4 and 7 pi over 4. So these are all your solutions. You will say t is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Remember, I'm not using k in this situation because I just want the 4 solutions between 0 and 2 pi. And that's all. And we are done with this problem. Okay? The smallest positive number for which tangent of 3x will be equal to 1. So we're going to answer this question. Again, what we will do, we will use the periodicity of tangent function. Now tangent is positive here. So I know tangent is positive either in the first or in the third quadrant, and because the magnitude of the value given is 1, it's either pi over 4 or it is going to be reference angle pi over 4 in the third quadrant. So the angle in the standard position is 5 pi over 4. So those are my two solutions, positive solutions. So what do I say? I say that the smallest positive number for which tangent 3x is 1, x is pi over 4. The next larger such number is 5 pi over 4. So again, I did not write the k solutions because I didn't want to. I needed only 2 solutions and I got both of them. Similar question, the smallest positive number for which sine 2x minus sine x is 0. So we're going to try to answer this question. This one will require you to remember the double angle formula for sine 2x. Remember, the double angle formula is 2 sine x cosine x minus sine x equal to 0. And I just need the smallest positive number solution. Now, in order to solve it, I'm going to factor out sine x from both sides, both of these terms. So I get 2 cosine x minus 1 equal to 0. So sine x is equal to 0, which means x is equal to either 0 or pi or 2 pi and such and such and such. Whereas the other solution is going to come from 2 cosine x minus 1, setting it equal to 0. 2 cosine x is equal to 1/2. So, first I said 2 cosine x equal to 1, then divide both sides by 2. So cosine x equal to 1/2. Cosine x is 1/2 at the reference angle of pi over 3. So in first quadrant, this is pi over 3. In the second quadrant, if the reference angle is pi over 3, then the angle in the standard position is 5 pi over 3. So those are the two solutions. But because I need the smallest positive solution, I am comparing between a couple of choices. First, sine x equal to 0 gives you the first positive solution at pi. 0 is not positive, so pi is your first positive solution. Whereas 2 cosine x minus 1 is 0 when x is pi over 3 or 5 pi over 3, and pi over 3 is the smaller one. Between pi and pi over 3, pi over 3 is the smaller one. So your answer is going to be pi over 3. Alrighty, so we'll carry on to the next page, and this one is asking to write all the solutions between 0 and 2 pi. And says keep the answer in multiple of pi, so you don't have to write down pi every time, just the coefficients. Do not use decimal numbers. The answer should be a fraction of an integer. Note that pi is already included in the answer, so you just have to enter the appropriate multiple. For example, if you have pi over 2, you just enter 1/2. If there is more than one answer, use a comma to separate them. So this one is saying 2 cosine t whole square minus cosine t minus 1 equal to 0. And this looks like a quadratic equation, so I can factor it. So what I do, I write it as 2 cosine square t, that's the same thing as cosine t whole square, minus 2 cosine t, and this is what I'm doing to factor them, minus plus 1 cosine t. And then I have minus 1 equal to 0. So from the first two terms, I factor out 2 cosine t and get cosine t minus 1. Then I factor out plus 1, still get cosine t minus 1 equal to 0. So I have 2 cosine t plus 1 times cosine t minus 1 equal to 0. So then either 2 cosine t plus 1 equal to 0 means cosine of t equal to negative 1/2, or cosine of t is equal to 1. Cosine t, 1 are quadrant angles. So I know that the solutions cosine t will be equal to 1 if and only if t is equal to 0 between 0 and 2 pi. That's the only solution. And at 2 pi, it is also going to repeat the value of 1. But what about negative 1/2? So think about when cosine takes the value of 1/2. So cosine will be 1/2 if the angle is pi over 3. So cosine is negative in the second quadrant, so the reference angle is pi over 3. That means the actual angle in the standard position is pi minus pi over 3, which is 2 pi over 3. Or it is negative in the third quadrant, and again the reference angle is pi over 3. So the angle in standard position in the third quadrant is pi plus pi over 3, which is 4 pi over 3. And those are the only two solutions where cosine t is negative between 0 and 2 pi. So now I have all my answers. So I'm going to write 0 for the first one. 0 times pi is 0, pi is 0. Then the second answer, I'm going to get 2 pi over 3, so I can say 2/3. Then I can say the third answer should be 4 pi over 3, so that's 4/3. And finally, 2 pi, so the answer is 2. And that answers this question. Find all solutions of the equation tangent to the power 5x minus 9 tangent x equal to 0. And the answer should be of the form ak pi, where k is an integer. What is a? Okay, so what I do first, I write the equation, and I realize that tangent is common in both terms. So I will get tangent of x, factor it out, and I will get tangent to the power 4x minus 9 equal to 0. Okay, so tangent x either is equal to 0 or tangent to the power 4x minus 9 equal to 0. What does that tell me? That tangent to the power 4x is equal to 9. I can take the fourth root on both sides, and I know that the left hand side will be absolute value of tangent x. The right hand side, if you take the square root of 9, you get 3, so I need one more square root, so that's square root of 3. So I get two solutions. I get either tangent x equal to positive square root of 3, or I get tangent x equal to negative square root of 3. If tangent x is 0, I know that the possibilities are x is equal to 0 and pi. And these are the easier situations because these are the quadrant angles. If it is, the magnitude is square root of 3, and that includes both cases for square root of 3 and negative square root of 3, then the reference angle, tangent is square root of 3 at pi over 4. Pi over 3, that is square root of 3. So when you are positive, you are in the first quadrant, and you are simply pi over 3. Or you are in the third quadrant, but for tangent, I can get by finding the solutions only in the first and second. Because remember, the period of tangent is pi. So the angle in the third quadrant where tangent is positive, you can just obtain by adding pi with pi over 3. So unlike cosine and sine, I don't care about the third and the fourth quadrant for tangent or cotangent. So that is the positive solution, whereas the negative solution will have pi over 3 as the reference angle. So the angle in the standard position is going to be 2 pi over 3. So how do I write my solutions? Remember, the first solution that we will get, that will be from tangent x equal to 0. So this is the integer multiple of pi. So I will say my solutions are k pi, that's one of the solution, or my solutions are k pi plus pi over 3, that's in the first quadrant when tangent is positive square root of 3. So this one you can write as, if I factor out the pi, I can write it as k plus 1/3, or I can get the solution as k pi plus 2 pi over 3. And again, I can factor out the pi and get my solution as k plus 2/3. And in all these situations, the general value for k is 0, plus or minus 1, plus or minus 2, and so on. But because I only wanted the solution of the form a times k times pi, and none of this or that are of that form, I will say the only solution is going to be k pi, and hence a must be equal to 1. So for the problem, a equal to 1 is your solution, but in general, if I ask you to give me the solution, you will say either the solutions are k pi or pi times k plus 1/3 or pi times k plus 2/3, where k equal to 0, plus or minus 1, plus or minus 2, and so on. Alrighty. Next page. Solve the following equation again between 0 and 2 pi, and this time sine t squared is 1/4. So simply take the square roots on both sides. You get absolute value of sine t equal to 1/2. So twofold solution, sine t equal to 1/2 or sine t equal to negative 1/2. So remember, for positive, sine becomes 1/2 at pi over 6. So in the first quadrant, so if it helps, I will write it down, is 1/2. So positive in the first quadrant, so that is pi over 6 here. Or it is positive in the second quadrant, so the reference angle is pi over 6. And the angle in the standard position is pi over 6. So that's just when sign is positive. How about sign is negative? Answers are either in the third or in the fourth quadrant, but I know the reference angle is pi over 6. So when I'm asked to find the angles in the standard position, one is pi plus pi over 6, so 7 pi over 6. And the other is 2 pi minus pi over 6, so 11 pi over 6. So I wanted the solution only in 0 and 2 pi, and I have all of those solutions. I would say the solutions are, again, I'm just writing the fractional coefficients. So that's pi over 6. Second one is pi over 6. Third one is 7 pi over 6. And the last one is 11 pi over 6. Answers my question. Pretty similar problem. This time you have absolute value of tangent t equal to square root of 3. So you get to say tangent of t is either square root of 3 or tangent of t equal to minus square root of 3. And remember, for tangent I just need the first and the second quadrant because the period is pi. So when it is positive, you're in the first quadrant, and square root of 3 we just have seen it is for pi over 3. In second quadrant I get the negative value, reference angle is pi over 3, so the actual angle in the standard position is 2 pi over 3. But I want the solution in 0 and 2 pi. So remember how I write it. I write it as k pi plus pi over 3 or k pi plus 2 pi over 3. Those are my solutions where k equal to 0, plus or minus 1, and so on, so on. Since I have only the positive solution as my requirement, I can forget about the minus signs. So if k equal to 0, then you get pi over 3. That's your first solution. Or you get 2 pi over 3, that's your second solution. Your third solution is going to be for k equal to 1, so that will be pi plus pi over 3, which is 4 pi over 3. So that is your third solution. And then finally we can go ahead and say that the final solution between 0 and 2 pi is going to be when k equal to 1, but I'm putting it in k pi plus 2 pi over 3. So pi plus 2 pi over 3. So when I add them, I get 5 pi over 3, and that's the last solution where tangent is in the fourth quadrant. So the answer will be 1/3, 2/3, 4/3, and 5/3. Alrighty. Similar problem, final solution between 0 and 2 pi. Again, looking at this thing, it looks like a quadratic equation with the exception of you have sine and cosine both. So what you want to do, change all of them to either sine or cosine. And it is easier to change all of them to cosine because I have the Pythagorean theorem or the Pythagorean identity for changing sine squared to cosine squared. So I have 2 sine squared minus 5 cosine x minus 4 equal to 0. So as I said, write sine square as 1 minus cosine square by the Pythagorean identity. That changes everything in cosine. So I get 2 minus 2 cosine square x minus 5 cosine x minus 4 equal to 0. I combine the like terms. So I get minus 2 cosine square x minus 5 cosine x. 2 minus 4 is negative 2, and that is 0. Of course, I'm going to factor. Remember, the coefficients are negative 2 and negative 2, so that's a positive 4. So I need two numbers that multiplies to positive 4 but adds to negative 4, and they are negative 4 and negative 1. So we'll factor accordingly. We'll say this is negative 2 cosine square x minus 4 cosine x minus 1 cosine x because of negative 4 and negative 1 minus 2 equal to 0. Factoring out minus 2 cosine square x and minus 4 cosine square x, negative 2 cosine x is common. So if I factor that out, I get cosine x minus 2. Then I factor out negative 1, and I still get cosine x plus 2. So it should be plus 2 equal to 0. So the two solutions are going to come from the factor negative 2 cosine x minus 1 and cosine x plus 2 is equal to 0. So either, now I get to say, the first factor, which is negative 2 cosine x minus 1 equal to 0, means negative 2 cosine x equal to 1, means cosine x equal to negative 1/2, or cosine x plus 2 equal to 0, so x cosine x equal to negative 2. Remember, range of cosine is negative 1 to 1, so that one will not give me any solution. So already I discard that. But cosine negative in second or the third quadrant, and cosine is 1/2 at pi over 3. So either the reference angle is pi over 3 in second quadrant, or it is pi over 3 in the third quadrant. So standard positions will be pi minus pi over 3, which is 2 pi over 3, or it is going to be pi plus pi over 3, which is 4 pi over 3. And these are the only two angles where we will get negative 1/2 for cosine, and those are the only two angles between 0 and 2 pi, and that's what we needed. So the coefficients we're going to write as 2/3 and 4/3. Alrighty. Solve the equation in the interval notation between in interval 0 to 2 pi. It's a similar problem. Again, I have a situation where it looks like I can factor things. For example, if you look at the first two terms, cosine t is in common. So let's take it out, and I get 2 sine t minus 1. Then I can take out plus 1 from the remaining two terms, because I want to ensure that I have 2 sine t minus 1 as the factor. So I get cosine t plus 1 times 2 sine t minus 1 equal to 0. Alrighty? So remember, cosine t plus 1 is 0, means cosine t is negative 1, and this is a quadrant angle. Cosine t is negative 1 only at pi. So the first one tells me t is pi, because I want the solution between 0 to 2 pi, and that's the only solution. Or else 2 sine t minus 1 is equal to 0, which tells me that sine t is 1/2. That is a positive sign. It can be in the first or the second quadrant, and sine t is 1/2 when the reference angle is pi over 6. So that's in the first quadrant. In the second quadrant, the reference angle being pi over 6, the angle in the standard position is 5 pi over 6. So I got all my solutions. The first and the smallest solution is pi over 6, so I write 1 over 6. The second one is 5 pi over 6, so I write 5 over 6. And the last one is pi, so I have to write the coefficient as 1. And these are the three solutions where we will have this equation true when t is between 0 and 2 pi. Alrighty? Cosine x, cosine 3x minus sine x, sine 3x equal to 0, and I want to find out 4 solutions between 0 and pi. The first 4 solutions between 0 and pi. So let's see. This is a formula. This is cosine alpha, cosine beta, so alpha beta, minus sine alpha, sine beta. Remember, the formula says that this is equal to cosine of alpha plus beta. So what I get to say? The left hand side is cosine of x plus 3x equal to 0. So cosine of 4x is equal to 0. Quadrant angle. So cosine is 0 at either pi over 2 or 3 pi over 2. So then solve for x. So I get x equal to pi over 8, 3 pi over 8. But then remember, I needed 4 solutions. So what you should do, you should write these two solutions in the general format first. So for example, if this is the situation, then I would say the general solution is x equal to, because the period of cosine is 2 pi, so one can say that, well, 4x, I would actually like to start by saying, is equal to 2k pi plus pi over 2, or is equal to 2k pi plus 3 pi over 2. Then divide both sides by 4. So that's the general solution, which means this one means x is equal to k pi over 2 plus pi over 8. And this one means x is equal to k pi over 2 plus 3 pi over 8, where k is equal to 0, plus or minus 1, plus or minus 2, etc. So remember, my first objective is to put k equal to 0. If I put k equal to 0, from the first equation, I get the solution pi over 8. If I put k equal to 0 in the second equation, I get 3 pi over 8. If I put k equal to 1 in the first equation, I get pi over 2 plus pi over 8. So let's see that. Pi over 2 plus pi over 8 if I put k equal to 1. So common denominator will ask me to multiply 4 on top and bottom. So I get 4 pi over 8 plus pi over 8, which is 5 pi over 8. That is my third solution. As you can imagine, now I'm going to use k equal to 1 in the second equation, and I will get pi over 2 plus 3 pi over 8. The same thing, to get the common denominator, multiply 4 on top and bottom. So you get 4 pi over 8 plus 3 pi over 8, and that's 7 pi over 8. So this is your fourth solution. And if you check carefully, all 4 of them are strictly less than pi units. And these are the 4 required solutions. Let's do a similar problem. This problem tells me that sine 3x plus sine x is equal to 0. And I want to solve this one for 2 solutions. Both of them should be in the interval of 0 to pi. As a hint, it is telling me use the sum to product formula. Remember, last class we have discussed if you add 2 sine terms, it should look like sine alpha plus beta and sine alpha minus beta. So I will say sine of alpha plus beta added with sine of alpha minus beta should be equal to 2 sine alpha cosine beta. That's the product to sum formula. So for us, alpha plus beta must be 3x. And alpha minus beta must be x. Again, I add these 2 equations. I get 2 alpha equal to 4x. So alpha equal to 2x. That means 2x plus beta is equal to 3x, which when you subtract 2x from both sides, beta is x. Which will help us a lot, because now instead of writing sine 3x plus sine x, what I will do, I will change it to the right hand side, or so to say sine 3x plus sine x. You can write it as 2 sine alpha, remember that is 2x, and then you have sine beta, and remember that is sine cosine of x. And that thing is equal to 0. So what does that mean? It means either sine of 2x is equal to 0, which means 2x is either 0 or pi, means x is equal to 0 when divided both sides by 2, or pi over 2. So I got 2 solutions that way. How about cosine? Well, cosine of x equal to 0 means x is equal to either pi over 2 or 3 pi over 2. And I'm going to write down the solution, and I see that pi over 2 is a common solution between both of them. And this answer of ours should be strictly between 0 and pi, so I can at once discard this solution because this is greater than 3 pi over 2 is greater than pi. So it cannot be a solution. So my solutions are 0 and pi over 2. So x1 is 0 and this is pi over 2. So that answers the question, and it is the end of our lecture here. So keep working on the homeworks. This is going to be a little tricky sometimes, but as long as we understand which trigonometric functions are positive, where they are negative, we understand the concept of reference angles, and we understand the period of sine is 2 pi, cosine is 2 pi, and tangent is pi, the solutions are not going to be difficult. Let me know if you have any questions.